Okay, good morning, class. So we're just wrapping up the quadratic equations and inequalities. Yesterday we were out of electricity. So we said we're going to look at the first column of 2.16 today. Part of our lesson we're going to look at the hand-in assignment, and we're going to have a look at what the problems were from the revision exercise. Okay, and then we're going to start as well the second part of the lesson with the geometry, if time permits. Okay, so let's start. As we know, it's a packed lesson. Let's just do a thing. So we started quadratic equations. And I gave you the first column to do for homework. Not so. So I said we're going to do a few of this morning. We're going to discuss problems, and we're going to do a few in this video as well. Okay, so it's 2.16. Right, so I'm just going to do it on the side and just erase as we carry along. Okay. Then you're going to, towards the end of it, you can tell me what you had a problem with the even numbers as you did that yesterday. Okay, so number one, here we go. So number one is x squared minus 9 has to be less than 0. Difference of two squares, x plus 3, x minus 3. The critical values, never say x is equal to. Say the critical value is of course negative 3 and 3. Take it to our graph, negative 3 and positive 3. This is, the graph has to be less than 0, which means to say it has to be negative. Above the line is positive, below is negative, so it's that part of the graph there. Okay. Is that the continuous or break-in solution? Continuous, so you must write it together. So x is greater than negative 3, but less than 3. The inequality will always be written like, if it's bunched together, the inequality is together, it's always written like this, provided that the smaller value is on the left-hand side. Okay? Or the value that's more negative. Let's look at number 3. Just let me know if I'm going wrong somewhere. Okay? So it's x squared minus 8x plus 12 has to be less than 0. Again, factorize. If you can't factorize this, use the quadratic formula. Okay? So we go x, 6 and 2, both negative. So my critical values is 6 and 2. Again, if you use the quadratic formula, you'll go straight from that into this here. Don't force your factors into brackets like this here. Do you understand? So rather go from the formula straight into that thing. Okay. So on our graph, we have 2 and 6. Of course, the one that's more negatives on the left hand side. It has to be less than 0. So is that above the line or below the line? Of course, below the line. As you see me shading it here already. So that's y is equal to 0. Above is positive, below is negative. So we are told that x is less than 0. So it's below the line. So x must be greater than 2, but less than 6. Okay, any issues here? No? You must get a sum like this in your final exam as well. Okay. Grade 12 final exam. Alright. That's why I'm spending some time on it. It's a concept often that learners doesn't understand how to answer. Okay. But you guys now know how to answer, not so? Right. Look at this factorizes into x and x, 8 and 2, plus and plus. So my critical values here is negative 8 and negative 2. We go negative 8, negative 2. It has to be more than 0, so it's above the line. Not so y is equal to 0, that's more than, of course, that is less than on that side. Okay, I think that's behind the calculator. Yes. So, okay. So is that a continuous or a break-in solution? Continuous or broken solution? The break-in solution. So we have x and negative 8 or x and negative 2. So this says that must be more than 0. So x in that direction, x is less than negative 8. In that direction, x is more than 2. So look at number 7. Number 7 is 4x squared. This will be greater than or equal to 9. Bring it over the equal sign is 4x squared minus 9 is greater or equal to 0. Difference of two squares is going to be 2x plus 3, 2x minus 3. My critical values or my zero values here, of course, is going to be negative 3 over 2 and 3 over 2. Take out to the quadratic function, the graph. It's negative 3 over 2 and 3 over 2. Okay. So it says it must be more than 0. So that's y is equal to 0. It's more than is above the line, and less than, of course, is below the line. As you can see, it's more than or equal to 0, so it's above. So it's this part here, and that part of the graph there. Not so. Is that continuous or breaking solution? It's break, so it must be apart. You guys understand? So we say x must be, you got negative 3 over 2, or x must be 3 over 2. So as you can see, going in that direction, it is less than, not so. So x must be less than negative 3. You see, there's an equal sign here as well. So there's one less than and equal to. Or x must be more than, that's going in the positive direction. More than or equal to 3. Okay. Any confusion here? No? Next one is number 9. So it's 2x squared plus 9x minus 5 is greater than 0. So this would simply be 2x and x, 5 and 1. So that's going to give you a positive and negative. So what do we say your critical values again? It's going to be a half and negative 5. So in our graph there's negative 5 and a half there. That is y is equal to 0. Above the line is more than, below the line is less than. We look at what is asked. There is a quadratic more than or equal, more than 0. So more than means to say above the graph line, not so. So it's going to be this part here and that part there. That's more than 0. So is this continuous or breaking solution? Breaking solution. So x and negative 1 or x and a half. So we say x must be that direction. X must be less than negative 1. Or x must be more than half. Any confusion there? The next one is number 11. Is 8x minus x squared has to be less than 0. Now remember, you can factorize the x and use that as is, but then your graph is going to go the other way around. Okay? It must be a maximum graph. Why? Because the coefficient of x squared is negative. But we made a note that said always try and write it in standard form. By writing it in standard form and taking account of the negative, the graph, your parabola will always have a minimum value. Okay? So if we rearrange here, it's going to be negative x squared plus 8x must be less than 0. If we divide by negative, what's going to happen to the inequality? Swaps around. So he's taking x out as a common factor. So your critical values here is going to be 0 for this one here and 8 for x minus 8. Not so? So now, there's going to be 0 and 8. If it's above the line, it's more than, below the lines, of course, less than. So what we say here? They say that the quadratic must be more than 0. So we're going to look where it is positive. And it's positive above the line. Not so? Is that a continuous or broken solution? Broken. So x 0 or x and 8. So it's going in this direction here. So x must be less than 0. Or x must be more than 8. You see that? Fairly simple, no? Once you understand the concept, it's easy to do it. Let's look at 13. In 13 we got 4x squared minus 4x minus 3. Okay, that factorizes into 2x times 3 is 6 minus 2 is 4. So you The critical values there is negative half. Is that correct? Huh? So there's negative half there and 3 over 2. What about the fact? Okay, so above the line is more than, less than, below the line is less. This is the function must be, or the quadratic must be less than 0. So is that above or below the line? Below the line. Below the lines, that's continuous or break-in solution? Continuous solution. It's going to be together again. Can you see that? So add that together, it must be then be x negative half 3 over 2. So x must be in that direction. X must be more than negative half but less than 3 over 2. Since that is equal, they must go equal as well. Okay, yes, what's the question? You see, it is from negative 2. The solution is from negative half to 3 over 2. The solution is together. It's continuous from one point to the next. There's no breaking. So when once the solution is together or continuous, then that is together. Okay. However, if it's apart, it's a break in the solution. So it will, your solutions will be apart. Okay. Your inequalities will be apart. That was number 13. You look at 15. Number 15, you got 3x squared minus 5x plus 2 must be greater than 0. That factorizes into 3 times 2 is 6. Minus 1 is 5. The critical values, of course, is going to be negative a third and 2. So it's negative a third and 2. Must be more than 0, so it's above the graph, above the line. This continuous or break-in solution? The break-in solution, so x has to be less than negative 3 or x must be more than 2. Okay. To number 17, it's going to be x squared minus 5. 5 must be less than 0. Difference of 2 squares. X and x, plus and minus, the root of 5 and the root of 5. Okay? Otherwise, you call a quadratic formula, you're going to get critical values to be plus minus root 5. Okay? Otherwise, we used to replace that inequality with an equal sign, same story. X equal to plus minus 5. Plus minus the root of 5. So that's going to be negative root 5. Root 5, that is y and y, greater than and less than. The question is, where is the quadratic less than 0? So it's this part here. Can you see that, people? You say x is greater than negative root 5 and x is less than the root 5. Okay? And the last one is going to go into a quadratic formula. I'm sure you know what to do. It's a continuous solution. Okay? Then you guys had an assignment to do. No? The ending assignment was the revision exercise from the Keeping Math Simple textbook. Not so? Okay. In example, through that exercise, I've addressed example 4 and example 5's solution as well. Okay. I'll take it off here. Okay, so let's go to the revision exercise. The revision exercise, we were on page 68. Right. Any issues with number 1? Number 2? Number 3? Number 4? Number 5? Yes, number 5 is the issue. Number 6? No? We'll do this afterwards. Number 5 is the problem, no? number 6, number 7, number 8, number 9, number 9, no, number 10, number 11, number 12, watch the video again, number 13, yes, watch the video again, okay, that was done extensively in the videos, okay. Okay, let's just do it. Before you tell me that one question you asked me I didn't do, and that's why you didn't get the A for maths. And alright, division exercise. Page, what is this? 68. Division exercise, page 68. Alright. Division exercise, page 68. We are told solve for x and leave your answer in third form. Okay, so importantly here, just get rid of the brackets. It's a binomial squared. With x squared, that times 2 is positive 6x plus 9 minus binomial squared. So they give you x squared plus 4x plus 4 equals binomial squared, which is x squared minus 2x plus 1. Okay. Now, just getting rid of the brackets, x squared plus 6x plus 9 minus x squared minus 4x minus 4 equals x squared minus 2x plus 1. Bring everything to one side, on the equal sign. So I'm going to the right hand side. So 0 is equal to x squared. Now, minus 2x minus 6 is minus 8x. Minus 8x plus 4x is the minus 4x. Is that correct? No? Then is 1 minus 9 is negative 8 plus 4 is positive 4. Not so. So this is simply going to give us x minus 2 squared, since it's a binomial square. So therefore x is equal to. What's this question? Yes, where you go now?
So by the constant raised x is equal to x squared minus 4x plus 4, I say minus 4.
Where?
You see by by the last line.
Well, this one.
Third law.
This one.
Yes.
Okay.
Minus 4.
You said minus 4 here.
Yes.
But you remember this is 1 plus 4 is 5. 5 minus 9. It's minus 4. You're right. So I'm wrong. Okay, so that's not a perfect square triangle. Nice. So that's going to take you to the quadratic formula. So x equal to minus b plus minus the square root of b squared minus 4ac over 2a. So x equal to 4 plus minus, that's 16, plus 16 is 32. No? So it's going to be 4 root 2. Is that correct? Okay, so you can take out 2 as a common factor, or 4 over 2 is 2, plus minus 4 root 2 over 2 is 2 root 2. Is that correct? No. Why negative 2? Is my substitution wrong? Is this wrong here? Okay, so my A value is 1, my B value is negative 4, and my C value is negative 4. So it's minus, minus, give you plus, no? Negative squared will always be positive. So it's going to be negative 4 times 1 times negative 4. So that's going to give you 16 plus 16, which is 32. Okay? 16 times 2, so it's going to be 4 root 2. That's right. Okay, let's just check. Okay, just hang on. So it's 2 plus. Don't just be quick to say the book is wrong. So you got 2 plus the 2 root 2. 2 plus 2 root 2. Okay? What's the answer in the book? So it's going to be answer plus 3. Answer plus 3 squared minus open brackets answer plus 2 squared minus answer minus 1. It should give you an answer of 0. If you do anything other than that, I made a mistake. That's correct. So we are right and the book is wrong. Okay. What's the answer they have? Minus root 2. So they made a mistake. Okay. Right, let's look at the next one. Question 6. It says solve for x correct to 2 decimal places. So yeah, definitely quadratic formula. So it's going to give you 9x squared minus 18x equals 4x plus 8. So it's 9x squared minus 18x minus 4x minus 22x minus 8 equal to 0. So this now has an a value of 9, a b value of negative 22, and a c value of negative 8. Okay, so x is equal to minus b, which is 20 minus minus 22, plus minus the square root of negative 22 squared. It's 22 squared minus 4. Your a value is 9. Your c is negative 8 over 2, and your a value is 9. Okay. Punch it in the calculator. It's going to be 22 plus the square root of 22 squared minus 4 times a times c over 2 times 9. If you said leave your answer in set form, then that would be the answer. Okay. But you want decimal, so it's 2 comma 7 7. So it's 2 comma 7 7, since that number, the third digit is greater than or equal to 5. And on the other end we have negative 0.32. Is that correct? Okay. Then simultaneous equation. Solve the following equations simultaneously for x and y. So, equation 1 we already have y is the subject of the formula. Do we have to change that? No. So whenever we see a y, we do it 2x plus 1. So x squared plus x into 2x plus 1 minus 3x minus 2x plus 1 plus 2 equals 0. So that's simply going to give us x squared plus 2x squared plus x minus 3x minus 2x plus minus 1 plus 2 is equal to 0. So that becomes 3x squared. That's going to give you minus 4x plus 1. Is that correct? So it's 3x and x, 1 and 1, both negative. Both negative. So x equal to a third or x equal to 1. Is that correct? Who got that answer? Okay, so what do we do with this? We sum it back. So y is equal to 2 times a third, which is 2 thirds, plus 1. It's going to be 1 and 2 thirds, or 5 over 2, and 5 over 3. The other end, y is equal to 2 times 2, which is 2 plus 1 is. Who asked this question? Where did you go wrong? Can't factorize. You make a mistake on factorization here. From there to there. Yeah. You didn't substitute it properly. Okay? Yeah, once that is messed up, and then you won't get nice factors out. People, when it comes to these sums, the solution to those sums are always nice rational factors. Okay, like nice numbers, not decimals. Okay, let's look at question 12. Question 12, we told that the plane flies 1,300 kilometers from Johannesburg to Cape Town. So you are having a table there. So Johannesburg to Cape Town, and the return Cape Town to Johannesburg. You got speed, distance, time, and the pyramid, D on top, speed and time. Okay. Normally we put D first, and then S. But if you had the other way around, no problem. A plane flies 1,300, it says 1,300 up, 1,300 down. From Johannesburg to Cape Town. On the return trip, there is a strong wind that slows the plane down by 50 kilometers. So we say let speed 1 equal x, or the outgoing speed from Johannesburg to Cape Town be x. So it's going to be 50 kilometers per hour slower. So it's going to be x minus 50. So the time here is 1,300 over x, whilst the time here is going to be 1,300 over x minus 50. Okay. So which time is longer? So we don't need this now, so we sorted it out. So we are told it takes him 15 minutes longer. Okay? Calculate the speed of the plane and the time taken for the journey from Johannesburg to Cape Town. So I must calculate x and I must calculate 1,300 over x. Okay? So which time is longer? Time 1 or time 2? Sorry? The second time is taking longer. So T2, which is 1,300 over x minus 50 minus 1,300 over x. We must see which time is longer. Why? Because otherwise it's going to go into a negative on the other side. You understand? That gives you 15 minutes, so 15 over 60. So your LCM here, your LCM, this I could have changed to 1 over 4. Okay? You could have changed it. So if you did not change it, it's also fine. Your LCM, of course, is going to be 60 x into x minus 50, which now gives us 1300 times 60x minus 1300 times 60 into x minus 15 equals 15x into x minus 15. After simplifying, you should get 0 equals 15x squared minus 750 x minus 3912123. So therefore, in your quadratic formula, x is equal to 535,51 kilometers per hour, or negative 485.51. Of course, it can't be negative. Not so. So that is the speed from Johannesburg to Cape Town. The time taken, the first time, is going to be 1300 over x, which is 535,51, gives me 2,43 hours, or, so if you got in your calculator 2,43, you minus the 2, you take that decimal, which is 0,43 whatever, you multiply that by 60, and you get 2 hours and 26 minutes. Sorry?
Minus the 2 times 60.
Minus?
Actually, minus the 2 and times that by 60.
Yeah. Because then what you're left with is 0,43 of an hour. Then why we times by 60? There's 60 minutes in an hour. Okay. So that's that. And then number 13. Number 13, we are told that two machines working together takes 4 hours 30 minutes to complete a job. One machine takes 1 hour and 15 minutes, less than the other machine, to complete the job, if the machine was working together independently. No. One machine takes 1 hour 15 minutes, less than the other machine, to complete the job if each machine was working independently. Complete how long will it, calculate how long it will take the slower machine to complete the job if the faster machine was broken. Okay, so let's call one machine 1. So we say let machine 1 equal x. Okay. Then machine 2 is going to be, as it's taking 1 hour 15 minutes less, so it's x minus 1 hour 15 minutes. So which one is the slower machine? Machine 1. Machine 1 is the slower machine, not so. So in 1 hour, you all okay with it, no? In 1 hour, therefore in 1 hour, how much of the job does machine 1 do in an hour? 1 over x. Okay? And machine 2 in 1 hour covers 1 over x minus 1 and 15 over 60. Okay, all agree with that? Just write this later. It's 1 over x minus 1 and 15 over 60. That's how much of the work it covers in 1 hour. So together, therefore together, what do we know? Calculate out 4 hours and 30 minutes. Not so. It is 4 hours, 4.5 hours. Therefore, in 1 hour, it's going to be 1 over 4.5 hours. Not so. So now with this is enough information to set up a formula, so we can say that 1 over 4,5 must be equal to, working together must be equal to machine 1, which is 1 over x, plus 1 over x minus 1 and 15 over 60. Okay. So from here, it's just a matter of solving the equation. Alright, so your LCM, of course, is 4.5x into x minus 1 and 15 over 60. So it's going to be 4.5 into x minus 1 and 15 over 60 plus 4.5x equals x into x minus 1 and 15 over 60. From here, it's just a matter of solving the equation, writing it in standard form. So 0 is equal to x squared minus 10.25x plus 5,625. Okay? So now gives us x is equal to 9,67 hours, or x is equal to 0,58. Now this here, 0,58 will never be the case, okay? Because 0,58 as the x value. If I say put that into here, it's going to give you a negative solution. Not so. So that's why I will be omitting that solution there. So the answer is 9 hours, 9,67 of an hour. Again, once you got that, you can subtract the 9 and you take the decimal, which is 0,7, multiplied by 60. Therefore, your time would be 9 hours and 40 minutes approximately. Okay. So that basically brings us to the end of the section of work. Have we marked everything to do with equations and inequalities? I remember we did a nature of roots of another exercise, no, of another chapter, of another textbook, sorry. Did we mark those sums already? Huh? Didn't we mark it? Yeah, the exercise 8. Let's just go there quickly. Okay, I think I deleted it already. Okay, so that basically wraps this up. Okay, so we're going to start our geometry now. I'll stop this video at this point.